Dr. Purpose here, National Anthem, like always. In additional classes done on HMT Academy online tuitions, just on Facebook. Just on Facebook. So we've been going through matrices, and I gave you work last time. So unfortunately, we've got a lot of questions to go through. So for us to finish them faster or quicker, let's just use Zoom so that we can quickly go through this. So the last video that I posted, we did the first question. So I'll try by all means to work throughout all these questions in the shortest period of time. Now, so what we have is very simple. So for the next question, we have given. So let's just magnify this a little bit further so that you can be able to see clearly. So given A is 2, 1, -5, -3. So we did the first one. Then the next one is saying if A is equal to 1x -1, 2, find A squared. Find A squared. Then 2 is saying values of x for which the determinant of A squared is 9. So values of x. So two values, of course, not one, but two values of x for which the determinant of A squared is so they've given us a figure, of course, is a 9. Is a 9. So definitely the answer should be something like a 3, 3. Because square root of A squared is square root of 9 is a 3. So let's just go to the solutions. A squared, A squared, A squared, A squared. So we know that for our A squared, so like I said, we shall try to be as fast but steady as we can. Fast but steady, of course. Have I chosen the wrong question? Give me a minute. Oh, I'm solving. Okay, now I understand. I was right. Given that A is equal to 2, 1, -5, -3, and B is equal to 6, 2, 4, and a 0. Find B minus 2A. Find B minus 2A. So 2A is 2. On that A is what is known as a scalar multiplier or scalar multiplier. That means it's 2 by everything that is in A here. 2 by everything that is in A there. So like I said, if you guys are looking at addition or subtraction, these guys must be of the same order for them to be added or subtracted. They must be of the same order, meaning it must be a 2 by 2, it must be a 3 by 3, it must be a 4 by 4 matrix. They must have the same order. You can't add a 2 by 2 to a 3 by 2 matrix. It's impossible, unless when you are looking at multiplication, maybe. But you can multiply a 3 by 2 and a 2 by 2 matrix, but you can't multiply a 2 by 2 and a 3 by 2 matrix. That's what I mean here. So we are finding B minus 2A, then we are finding B times the inverse of A. B times the inverse of A, of which you know that when you're finding the inverse of A, you find the determinant, then 1 over the determinant, then these two swap, 3 goes there, 2 comes down, these change signs, A -5 will become +5, +1 will become -1. So let's go to our solution. It's B minus 2A. B minus 2A. B minus 2A. b minus 2a, b minus 2a. So our b is a 6240. That's our b. Then it's 2 times a, 2 times a. So it will be 2 by 2, that's a 4. 2 by 1, that's a 2. Then 2 by negative 5, that's negative 10. 2 by negative 3, that's negative 6. Like that. So what we'll be having is a b now, it's a 6 minus 4, because it's the first one minus the first one. So it's 6 minus 4, 2 minus 0, then 4 minus negative 10. 4 minus minus 10. So we know these negatives, these two negatives. So this is a subtraction, it's an operation, then that is a sign. So we know negative, negative, positive. Then 0 minus negative 6, 0 minus negative 6, 0 minus negative 6. So negative, negative, again, positive. So what do we have here? We have this now. So you've seen here 6 minus 4, 6 minus 4. Then 4 minus negative 10. So negative, negative, positive here. Then 2 minus 2, 2 minus 2. Then 0 minus negative 6. So negative, negative here, positive. So 0 plus 6. 0 plus 6. So 6 minus 4, that's a 2. Then 2 minus 2, that's a 0. 4 plus 10, that's a 14. 0 plus 6, that's just a 6. So this is the answer for the first one. This is the answer for the first one. This is the answer for the first one on this one, of course. Then we are finding b times the inverse of b. B times the inverse of a, rather. B times the inverse of a. B times the inverse of a. So what do we know about the inverse? What we know about the inverse is very simple. It's the major diagonal, product of the major diagonal minus product of the minor diagonal. Product of the major diagonal minus product of the minor diagonal. That means it's 2 by negative 3, 2 by negative 3, 2 by negative 3 minus negative 5 by 1. 2 by negative 3, then minus negative 5 by 1. So going to next. So it's 2 by negative 3, that's negative 6, minus negative 5 by 1, that's negative 5. So it will be 6, negative 6 minus negative 5. Negative 6 minus negative 5. So we know that it's negative 6. Yeah, that's a powerful 6. Minus negative 5. So we know that negative, negative, positive. So it's negative 6 plus 5. Negative 6 plus 5. So we know that negative 6 plus 5, it's 5 steps to your right and 6 steps to your left. And you end up at negative 1. And you end up at negative 1. So the answer for this one is negative 1. The answer for this one is negative 1. So we can now go to the next. We can now go to the next. So we can just clear this out. Let's just clear this out. So let's just clear this out a bit. We just clear this out. It's out like that. So we got the next one, the one that I read earlier. So take this guy down. So they're saying that a is equal to, if a is equal to 1, x negative 1, and a 2, find a squared. Find a squared. So this is a 2 by 2 matrix. That means your answer will also be a 2 by 2 matrix. So in this one, we don't have one number on one of the things that we have. What we have there is x. So it's just the same. It's just the same thing that we have. So let's see. I think it's should be, it should be, where's the solution? So, oh, before we proceed, oh, I rushed on this one. So our determinant was negative 1. So we were not finding the determinant, rather. We were not finding the determinant, but it's b by the inverse of a. It's b by the inverse of a. So let's find the inverse of a. I'm sorry for that. Let's find the inverse of a. So since we know our determinant is negative 1, so we know it's 1 over negative 1. 1 over your determinant. 1 over negative 1. That's what we have here. So it's 1 over negative 1. That's what we have. So a inverse is 1 over negative 1. So like we know, these would have swapped already. These would have swapped. How? So I said that the negative 3 goes there on top, and the 2 comes here down. So the 3 will be there, just like it is here. The 2 come there down. Then these will swap their signs. So negative 5 will become a positive 5. Then positive 1 will become negative 1. That's negative 1. So we know that 1 over negative 1 is just negative 1. 1 over negative 1 is just negative 1. That means what you'll be having outside here is a negative 1. What you'll be having outside here is a negative 1. So it's negative 1 by negative 3. So negative 1 by negative 3, that is positive 3. Negative, negative, positive. That's why there's a 3 here, positive. Then negative 1 by negative 1, positive 1, a positive here. Negative 1 by 5, that's negative 5, like that. Negative 1 by 2, that's a negative 2. That's what you have here. So 1 over negative 1 will give you negative 1. Then the negative 1 by everything that is here, like inside the brackets. So it's negative 1 by negative 3, positive 3. Negative 1 by 5, negative 5. Negative 1 by negative 1, positive 1. Negative 1 by 2, negative 2. That's what you have. So this is your inverse of A. So they have said B times the inverse of A. So we can now multiply B times the inverse of A, of which we know that this is our B, and that's the inverse of A. So it's 6 by 3 plus 2 by 5, by negative 5, of course. 6 by 3 plus 2 by negative 5. That's for the first one. Then for the next one is 6 by 1 plus 2 by negative 2. 6 by 1 plus 2 by negative 2. Then the next one down here, it's 4 by 3. 4 by 3 plus 0 by negative 5. 0 by negative 5. So it's 4 by 3 plus 0 by negative 5. Then 4 by 1, 4 by 1 plus 0 by negative 2. 4 by 1 plus 0 by negative 2. So let's see what we have here. So 6 by 3, that's 18. 18. 6 by 3, that's 18. Plus 2 by negative 5, that's negative 10. So it's 18 plus negative 10. 18 plus negative 10. Yet again, let's write our nonsensical numbers here using our wonderful pencil. So it's 18, 18, of course. It's 18. So I'm trying to make this right. I wonder why it's floating in the air. Doesn't really make sense. So this should be settled down. 18 plus negative 10. So I'm just trying to show you so that you can see what happened. So positive, negative, it's a negative. That means it's 18 minus 10. 18 minus 10, which is equal to 8. That's the 8 that we have there. 18 minus 10, that's equal to 8. Then down here, let's take this down. Okay, let's do this guy. So 6 by 1 is a 6. 2 by negative 2, that's negative 4. That means again it's 6 plus negative 4. 6 plus negative 4. So positive, negative, that's a negative. So it's a 6 minus 4, which is equal to a 2. So my cursor is really misbehaving. It's really misbehaving. So it's 6 plus negative 4. So it's just 6 minus 4. That's a 2. Then down here it's 4 by 3, that's a 12. 0 by negative 5, that's just a 0. So it's 12 plus a 0, which is just, of course, a 12. Then 4 by 1, that's a 4. 0 by negative 2, that's just a 0. So it's just a 4. It's just a 4. So these are the answers for the second question. These are the answers for the second question. These are the answers for the second question. So these guys were just making minor mistakes in terms of typing. I think it's the guy who was typing. If you've noticed, some other questions had signs omitted. Some other questions had signs omitted. So it's fine, but the final answers are all correct. So if A, so this is the second question. If A is equal to 1x negative 1, 2, find A squared. Find A squared. Find A squared. Find A squared. So yet again, A squared, we go down to the next, A squared. A squared. So it's this by that, like that. So it's 1 times 1 plus x by negative 1. 1 by 1 plus x by negative 1. That is 1 by 1 plus x by negative 1. Then 1 by x plus x by 2. 1 by x plus x by 2. That's what we have here. Down here, negative 1 by 1. Negative 1 by 1. That's what we have here. Plus 2 by negative 1. Plus 2 by negative 1. That's what we have here. The next one, negative 1 by x. Negative 1 by x plus 2 by 2. Negative 1 by x plus 2 by 2. So we know that 1 by 1, that's just 1. X by negative 1, negative x. Then 1 by that x, it's just x. X by 2, 2x. Negative 1 by 1, negative 1. 2 by negative 1, that's negative 2. Negative 2. Then negative 1 by that x, negative x. Then 2 by 2, that's a 4. So simplifying this further, what we have, 1 by x is just this x. 1 minus x, of course. Then negative 1 minus 2, that's negative 3. X plus 2x, that's 3x. Then negative x plus 4, that's just equal to negative x plus 4. So this is the answer for this one. This is the answer for this one. So it's just multiplication of matrices. Then next, find the values of x for which the determinant of a squared is 9. Find the values of x for which the determinant of a squared is 9. 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 So it's very simple. We know our determinant is equal to the major diagonal product of the major diagonal. Product of the major diagonal minus the product of the minor diagonal. Product of the major diagonal minus product of the minor diagonal. Product of the major diagonal minus product of the minor diagonal. So I want to try out something, because they're saying the values of x is negative 5, and 1. So let's try and work out something. Let's try and work out something that will be somehow, let's say, somehow better. Let's see if it will work. Let's see if it will work. Now, they are saying a squared is equal to 9. A squared is equal to 9. So let's use our scruffy pencil. Let's use our scruffy pencil again. So if a squared is equal to 9, if a squared is equal to 9, if a squared is equal to 9, then what you do, you square root. So this guy must really behave itself, really. This one must really behave itself. It's really misbehaving. So square root, you square root both sides. So square root of 9, that means a is equal to positive or negative 3. Positive or negative 3. That's the value of a. That's the value of a. So I've just done the square root of a, square root of 9. That means a is positive or negative 3. Positive or negative 3. Positive or negative 3. Positive or negative 3. That's the value of a. That's the value of a. So let's try and work out some magic here. Let's try and work out some magic. So I've just done square root of a, square root of 9. That means a is equal to positive or negative 3. So let's go back to the question. A is a is a is 1, 2, negative 1 x. 1, 2, negative 1 x. So let's find an expression for the determinant of a. Just an expression for the determinant of a. Not a squared, but just a. Just a. Just a. So we shall just use this very place. So we are finding notation for the determinant of a. So it's 2 by 1. So it's 1 by 2. 1 by 2. 1 by 2 minus, open brackets, negative 1 by x. Negative 1 by x. So negative 1 by x. So we know that 1 by 2, that's just a 2. 2 minus, open brackets. Open brackets. Open brackets. 1 by negative 1 by this x. That's negative x. Yeah, that's negative x. So this is a very wonderful, yeah. So it's 2 minus negative. 2 minus minus. So minus minus positive. That means it's 2 plus x. 2 plus x. 2 plus x. 2 plus x. So we are trying to prove something here. We are trying to prove something. So I have just found an expression for the determinant of a, not a squared. Not a squared. I've just found an expression for the determinant of a, not a squared, but just that of a only, not a squared. I've just found an expression for the determinant of a, not a squared. So I would really want you to digest this in your mind. I would really want you to digest this in your mind, because I really don't want you to be confused after this is all said and done. I don't want you to be confused after this is all said and done. I don't want any confusion. So if some of you might be wondering why I'm using another method. So there are normal methods of solving which are longer, and there are other normal methods of solving which are shorter. So I'm trying to use a shorter way of solving this. I am trying to use a shorter way of solving this. I am trying to use a shorter way of solving this. So I'm trying to use a shorter way of solving this. Like that. So if we can go back to what we were finding. So they are saying that determinant of a squared, determinant of a squared is a 9. Determinant of a squared is a 9. What if you just found that of a only? That of a only. That means if you are finding that of a only, you square root both sides. You square root both sides. That means it's the square root of a squared and the square root of 9. Square root of a squared and the square root of 9. Square root of a squared and the square root of 9. Sorry for that. Square root of a squared and the square root of 9. That means discriminant of just a must equal to positive or negative 3. Positive or negative 3. Why? Determinant of a squared is a 9. Square root of that is just positive or negative 3. It's just positive or negative 3. So you can work your way around two methods. You can work your way around two methods. So there's the other one that I just showed you, the one that's in the solutions. The one that's just in the solutions of this paper.